In this lesson, we're going to go over solving systems of linear equations in two variables, and we're going to be really talking about applications. So our objective is to solve application problems using systems of linear equations. So what we'll be given is a scenario, typically a modeling scenario or something that you might find. We'll be able to assign x and y, or whatever variable names we use, to two unknowns. And we'll be able to use the information in the problem to form two equations that have our two unknowns, which turns it into a linear system in two variables that we know how to solve. So solving application problems, step one is to make sure you understand the problem. I typically recommend reading the problem at least 2 times and trying to visualize it. Step two is to solve the problem. So use the resources and tools that you know from this class as well as what's given in the problem to solve the problem. And step three is to explain the answer. Does the answer make sense in context of the problem? So example 1. The U.S. House of Representatives has 435 members. After a certain election, there were 17 more Republicans than Democrats with no other parties represented. How many members of each party were there in the House? So I would encourage you to read it again. Okay, so typically what I try to do first with these problems is I try to figure out what are the two unknowns here that I'm trying to find. Usually the last sentence tells me. How many members of each party were there in the House? So I'm trying to find the number of Democrats and the number of Republicans. So I'm going to use the variables D to represent Democrats and R to represent Republicans. Okay. Now when we have two variables like this, we're typically looking for two equations. And the way that we form the equation is by using the information given in the problem in order to form the equations. So in this case, we have the U.S. House of Representatives has 435 members. From the problem, we know that the 435 members are comprised of Democrats and Republicans. So we know that the number of Democrats plus the number of Republicans is equal to 435. So that's one equation. The next equation has to do with there were 17 more Republicans than Democrats. So for instance, if there were 20 Democrats, that means that there were 37 Republicans, 17 more. So the number of Republicans is equal to the number of Democrats plus 17. And there we go. We have our system, and we could use one of the methods that we discussed previously to solve the system. Here, I'll probably use substitution, and I'll do that on the next slide. So we have D plus R is equal to 435, and we have Republicans is equal to Democrats plus 17. The reason I'm choosing substitution is because we have the variable on one side in that second equation by itself. So we're going to take R in the second equation and substitute it into the first. So this leaves us with D plus 17 as R equal to 435. So what we do here is we solve this just like a linear equation. So we have 2D plus 17 equals 435. To solve, we subtract 17 from both sides. Okay, and then we'll go up here to have 2D is equal to 418, divide by 2, divide by 2. And our number of Democrats is equal to 209. Okay, and now you can plug in this value or use what you know. This should say 17 from the problem, and knowing that there are 17 more Republicans, you can just add 17 to this number, whatever will work best for you. So if we take number of Republicans is equal to Democrats, so 209 plus 17, we will get 226. Okay, so this will answer the question of how many members of each party were there in the House. There were 209 Democrats and 226 Republicans. Let's move on to a different type of example. You invested $5,000 between two accounts paying 2% and 7% annual interest respectively. So you earn money called interest on like a deposit you make into a savings account or a different type of investment account. So you earn a percentage of the whole. Okay. If the total interest earned for this year was $150, how much was invested at each rate? So read it again if you want. But again, sometimes the last sentence will tell us what our two variables are. We want to know the amount invested at 2% and the amount at 7%. So those can form our two variables. Okay, for this problem, I'm going to make a table just as another strategy as to how to organize and solve the problem for your work here. So we have an amount at 2%, and we have an amount at 7%, which is y. Okay, and then our two pieces of information here, it's not a very good line, our two pieces of information here that we're given are we have a total amount invested, so amount invested, and we also have the total interest for each. Okay, so then we have interest. And here we're going to call this our totals. Okay, so we were told that this person invested $5,000 between two accounts. So for the total and the amount invested, we know that this is $5,000. Okay, and for the amount of interest earned, we're given that's $150. So we put that in our totals. Okay, so now let's deal with the variables. So the amount that we're investing at 2% is X, and the amount that we're investing at 7% is Y. And X plus Y has to equal 5,000 because the amount we invest in one account plus the amount we invest in the other account has to equal the total amount, 5,000. With interest, remember that we're earning a percentage of the whole of the total that's invested, and that's the part. So when we talk about calculating interest, our interest is really playing the role of part, and then we have the percent and the whole. If we multiply the percent times the whole, we get the part or the interest. So that will come into play because the interest for this first row is 0.02x, so 2% times whatever amount is invested in that account. And for the second, it would be 0.07y, 7% of whatever is invested at that account. So what we can have here is x plus y is 5,000, so the amount invested at 2% plus the amount invested at 7% is equal to 5,000, and then the interest earned on each, 2% for the first, 7% for the second, is equal to 150. So now we can form our two equations. So we have x plus y is equal to 5,000, and then we have 0.02x plus 0.07y is equal to 150. Okay, you can use elimination or substitution. What I may do for this one is solve the top one for y and substitute it into the other one. So if this is solved for y, this is y equals negative x plus 5,000. Okay, and so now we're going to take that and substitute it in for y in the second equation. So we have 0.02x plus 0.07 times negative x plus 5,000 equals 150. And now we solve this like we do a linear equation. We have 0.02x plus 0.07 times negative x is negative 0.07x, and 0.07 times 5,000 is 350. Okay, so you would keep going from here, so I'm going to combine my like terms, and I'm going to move the 350 over to the other side to get negative 0.05x is equal to, this would be negative 200. Divide by negative 0.05 to solve for x. And this gives us 4,000. So x is equal to 4,000. And we could substitute that into either equation to find y, or remember that we invested 5,000 in total. If one amount is 4,000, then that means the other amount has to be 1,000. Okay, so this is saying that we invested $4,000 at 2% and $1,000 at 7%. Okay, we're going to get into a few more types of applications. Next, equilibrium and break-even points. So these are mainly, you'll see in economics courses or business courses potentially. Both terms are describing the solution of a system, but they have meaning in the context of the problem. So first, equilibrium point. So let's say you have an equation for supply, your supply equation, and an equation for demand. Something like this. They could be different. The point where they intersect is called the break-even point. That means that the supply is equal to the demand. What that also means is that there's not a surplus of product or a shortage of product. Okay, so that equilibrium point is helpful to know. The next is called a break-even point. So let's say we have a cost equation and a revenue equation. So cost, revenue. The break-even point is where cost equals revenue. Okay, so revenue might be how much you sell something for. So profit is equal to revenue minus cost, which means how much money you profit equals how much you sold the product for minus how much it cost you to make it. So let's say it cost you $50 to make an item and you sold it for $75. Your profit would be $25 in that case. Okay, so your break-even point means that you're not losing money, and you're also not earning money, or you're not making a profit. It's right at the middle there. Not at the middle, but the cost is equal to revenue. Okay, so let's do an example. Find the number of units that must be produced and sold in order to break even. So we have our cost equation is equal to 16x plus 400, and our revenue equation is equal to 18.5x. To find the break-even point, remember, we want the cost to be equal to the revenue. So I know that we see different variables, we see C and R, but the break-even point is when they're equal to each other. So we can set C equal to R. C is 16x plus 400, and R is 18.5x. Okay, so we solve this like we would any other equation. I'm going to move 16x to the other side to get 400 is equal to 2.5x. And then we divide both sides by 2.5 to get x is equal to 160. So 160 units have to be produced and sold in order for this scenario, for the break-even point of this scenario. Okay. Next, we're going to talk about commission and linear equations. So commission is a percentage of sales that you earn. So for instance, let's say you're at a job and you earn 10% commission on sales. If you sell $100, like let's say you have $100 in sales, how much do you earn in commission? What this is saying is 10% of 100, which as we've done the triangle before, this means 0.1 times 100 to give $10. So the commission on that for you would be $10. Okay, the next thing I want to go back to is our linear equation, y equals mx plus b. So m, remember, is our slope. Slope can also be thought of as a rate of change. So if you earn $100 per week, $100 would be the slope. It's what's changing every week by the same amount in that time interval. B can be thought of as your starting point. Okay, so let's say you have a $20,000 car that decreases in value by $2,000 each year. And you're in Math 124E, and so you want to write a linear equation to model this scenario. So in this scenario, the decreasing by 200,000 each year, it's decreasing by the same amount in the interval of time. So this would be our slope. Okay, the 20,000 is the starting point, B. So our equation here would be y is equal to negative 2,000x plus 20,000. It's negative 2,000 because the car is losing value, it's decreasing, so we have to have a negative sign there. So these couple of points will help us in our next set of problems. First, we'll learn to calculate commission. So just finding the rate of commission. So find the rate of commission if the sales are 8,000 and the commission is 1,200. You can think of these as part, percent, and whole. In this case, this is the whole, or the number of sales. And then the commission is the part, and we're looking for the percentage. Okay, so we can use the triangle that we talked about before, where the part is 1,200. We're looking for the percent, and the whole is 8,000. Remember, if they're on different levels, we divide. So 1,200 divided by 8,000, and we get 0.15. So we're asked to put this as a rate or a percentage. So this would be 15%. Okay. Next, example 2, determining the better plan. So you can be paid in one of two ways for furniture sales, let's say. The first plan, Plan A, is a salary of $1,000 per month plus a commission of 10% of sales. So what this means is no matter how much you sell in the month, you're going to get $1,000 that month. Okay, so even if your sales is zero, you're going to get $1,000. Plan B, salary of $1,200 per month plus a commission of 15% of sales in excess of $8,000. So you're only making commission on anything over $8,000. For what amount the monthly sales is Plan B better than Plan A, assuming your sales are always over $8,000? So what we can do is we can use our knowledge of linear equations in order to convert Plan A and Plan B into linear equations and then come up with an inequality because we're looking for more than in order to find the answer to this problem. So for plan A, our starting point is $1,000. So this is going to be or play the role of B, or the y-intercept. So again, no matter how much furniture you sell, you're earning that $1,000 plus 10% of sales. So let's call X sales, and you would be earning 10%. Okay, so you sell something, you get 10%. You sell something, you get 10%, and so on and so forth. Okay, so for plan B, this one is working a little bit differently. So we have a salary of $1,200 per month, which you're always going to get. So that's going to play the role of B. Now the commission here is you're only getting 15% if your sales are more than 8,000. So you'd have to sell 9,000 or 10,000, and you're only getting commission on the amount over 8,000. So instead of X, we're going to call this X minus 8,000 because it's our sales total minus 8,000 that we're actually earning commission on, and this would be 0.15. So we have our two equations, 0.1x plus 1,000 and 0.15x minus 8,000 plus 1,200. Now the problem is asking us for what amount of monthly sales is plan B better than plan A, assuming sales are always over 8,000. So if we want to know what it's better, we're talking about greater. So we can take plan B, put it greater than plan A, and solve from there. So we'll do this on the next slide. So plan B we want to know when it's more than or better than plan A. Okay, and so now we have our inequality, and we can solve this like we've done before. So we'll first distribute the 0.15. So this is 0.15x minus 8,000 times 0.15, which is 1,200, plus 1,200 is greater than 0.10x plus 1,000. Okay, and so now we get our x's to one side, our numbers to the other, and then we can solve for x. So notice on the left-hand side, negative 1,200 and positive 1,200 cancel out. So I'm going to move the 0.1x over to the other side to give me 0.05x more than 1,000. So we divide both sides by 0.05. And we get x is equal to 20,000. So plan B is better than plan A in the case that the sales earnings is $20,000 or more. Okay, or rather this should say more than 20,000, not or equal to, but more than. So $20,001 or 1 penny, but more than that amount. Thank you for watching. If you have any questions, please feel free to reach out to me.